Our graph analysis number 2 question was from the 2018 exam. The mean score is 3.36. And in this graph, I am given a graph of g, but I'm told up here that g is the derivative of f, so g equals f prime. And my function is piecewise linear, so these are all linear pieces from -5 all the way to 3. And then once I hit 3, from 3 to 6, I have this quadratic equation that my function follows. In part A, I'm given f of 1 equals 3, and I'm asked to find f of -5. This is our little twist on position that we're going to use. So we start with our known value. So f of -5 equals f of 1 plus our integral. Our lower limit is the 1, our upper limit is the -5. And what belongs here is the integrand is the derivative of f, which is, you could either call it f prime or you could call it g. You can actually use these two interchangeably. I see my limits are backwards, so my next move is going to be to switch them around and get that lower limit as the lower number. What that does is it puts a negative out in front, and at the same time I also replaced f of 1 with its value, which is 3. It would be okay for you to start the problem at this point right here, so you could put that 3 in right away, and you can also get those limits in the correct order as long as you remember to put that negative out in front. You're going to earn this first integral point with either this integral here, or if you have the limits in the correct order with that negative out in front, that would do it as well. In order to evaluate this integral, I'm going to look at the graph of g of x, which is over here. From -5 all the way to 1, I'm going to take an area approach. This is a trapezoid. You can find that area using a rectangle and a triangle if you want to. Either way, that's going to give me a 10.5, and the area of this little triangle from 0 to 1 is a 1. Because the 10.5 is below the x-axis, when I do the integral, I have to take it as a negative. The little triangle is above the x-axis, so that's a positive 1. This would be an okay answer right here. You don't actually have to simplify. But if you did, you would get a final answer of 12.5. In part B, I'm asked to evaluate the integral from 1 to 6 of g of x dx. Because my function is given in two pieces, I've got this piecewise linear from -5 to 3, and then from 3 to 6, I have that quadratic. I need to split this integral into two parts. From 1 to 3, I'm just going to use my graph of g of x to evaluate that integral, so I'm going to take an area approach from 1 to 3. And then from 3 to 6, when I get to that parabola shape, I'm going to find the area by actually doing an antiderivative of 2 and quantity x minus 4 squared. There are different ways to handle evaluating that integral. You could expand that binomial out and then find the antiderivative that way. I did it as a u substitution, which you see here off to the side. Either way you do it, when you do that antiderivative is what's going to earn you this point right here. So splitting it into two integrals earns the first point. Finding a correct antiderivative, even if you did it slightly differently than I did, is going to earn you that second point. And when that is all calculated, we get a 6, and then I pull that 6 back into the problem. And my final answer of 10 is what's going to earn the third point in part B. In part C, I'm asked where f is both increasing and concave up. I know that f is increasing where f prime is positive. So positive means totally above the x-axis. And I also know that f is concave up where f prime is increasing. So putting both of those together, I need to be above the x-axis and also increasing. Puts me from 0 to 1 is one interval, and from 4 to 6 is the second interval. And then I just put what I was looking for in my explanation. So f is increasing and concave up on the interval from 0 to 1, and again from 4 to 6. So 0 to 1, 4 to 6. Those two intervals are worth 1 point. If you missed something on one of them, you just don't get that point. So they have to be totally correct to earn the first point on part C. You could have them in brackets, and that would be okay. Our reason is because f prime is increasing and positive. Make sure that you always reference f prime by name in your explanation. You could call it g if you wanted to, but f prime or g. You don't want to generically say it or the graph. You want to always use the names. In part D, I am asked for the x-coordinate for the point of inflection on the graph of f. And I can see in my fun chart, a point of inflection is going to happen in between these two columns here. On my f prime graph, it's where f prime goes increase to decrease, or vice versa. And the only place that happens on this graph is where I go a decrease to an increase is here at x equals 4. This is a flat line right here, so I go from a constant function to an increase, so that doesn't count. Here's an increase to a constant, that doesn't count. And then to an increase, to a constant, to a decrease. So the only place I go from a decrease to an increase, or the other way around, doesn't happen at all, is here at the x equals 4. And then I just say that as my reason. And as we said in the previous video, you could say because f prime has a relative minimum at x equals 4, that would be an okay reason as well.